All right, so in this second video, we're going to talk the about different graphs of exponential functions. We saw the basic one in the first video. So just as a reminder, when a is greater than 1, it looks like that. It's an increasing function. When a is between 0 and 1, it looks like that. We start off with the y-intercept being 0, 1. So obviously, if we have, say, y equals 2 to the x, when x is 0, 2 to the 0 is going to be 1. So the y-intercept is 1 before we do any shifting. So all the shifting rules that we saw earlier in this course still apply. The vertical transformations, the horizontal transformations, the stretches, the reflections, all of those are the same, no matter what type of function you have. So exponentials are not going to be any exception. So if we have y equals 2 to the x minus 3, so here is 2 to the x, we're going to shift this down 3. So instead of the y-intercept being 1, the y-intercept is going to move down 3, and so that'll put it at -2. The other thing to consider, we have a horizontal asymptote here at 0. That is going to be shifted down 3. And so now we'll have a horizontal asymptote at -3. And you can think about that also as x gets really large. Well, as x gets large in the negative direction, this will go to 0, and so the function will be at -3. So increasing function, and it will look something like this. And we're not worried about where the x-intercept is. That's for a later section. And of course, these are multiple choice graphs on, maybe not of course, but there are multiple choice graphs on WebAssign. So it's mostly a matter of figuring out if this is an increasing or decreasing function, and then working on the shift from there. And I think the easiest way to work on the shift is figure out what happened with the y-intercept. The y-intercept is the one point that you can usually plot, and you can usually figure out where the asymptote is. So the domain, like I said, the domain on all these is going to be all real numbers, pretty much without exception. I don't remember seeing an exception in the homework. The range, you can figure out, looking at the graph, wherever the asymptote is, it's going to start there and then either go up or down depending on what else is going on with the function. So this one is never going to be inclusive of that number. It's all because that number is always going to be the y-intercept, or the horizontal asymptote, I should say. So we're not going to include that one. And then it's going to either go up to infinity or down to -infinity, depending on things. And then the asymptote, like we said, is y equals -3. So whatever that number is, that is always going to be your horizontal asymptote on these. All right, next one, we have 10 to the x plus 3. So now this one is going to be a horizontal shift. And this is a little bit harder to draw, I guess. We could figure out, well, when x is 0, I mean, we could figure out the y intercept. And when x is 0, we have 10 to the third, so the y-intercept would be 10,000. Now, this is a horizontal shift. It is not a vertical shift. And so also, the bigger this number is, the steeper the graph will be. For instance, if you had 1.1 to the x, that would be a pretty flat graph. And then the bigger the a gets, the bigger that base gets, the steeper it becomes. So just because you have a y-intercept of 1,000 doesn't mean it's not going to still come down here. So it is, we don't have a vertical shift, so it is still going to come down there, and it's just going to get steep really fast. But also, when x is -3, we'd have 10 to the 0. So now the y-intercept, the original y-intercept of 1, is going to be over here. It's going to be shifted 3. So I guess we could put there's the original y-intercept that moved from 0, 1 over to -3, 1. Domain, again, all real numbers. Range, no vertical shifts, so the range is not going to change. Horizontal shifts would normally change the domain, unless it's all real numbers, and then they don't. The range 0 to infinity, and then the asymptote has not changed either. That's still going to be y equals 0. So really, as long as they're horizontal shifts, nothing is really changing on any of these. They're all pretty much the same. We're just moving it left and right. And that's pretty much it. All right, next one. Oops. All right, so now we have a couple of things going on here. The negative there, if you remember from earlier section, that's a reflection over x. And then, of course, that is a vertical shift. That's a V, vertical shift. So let's see what that looks like. So the original, so 1/3 to the x would look like this. If we do negative 1/3, we're going to flip it over here, so it's going to look like that. Then we are going to shift it up 2. So the original y-intercept would be 0, 1. We reflect it over the x-axis. So now the y-intercept of negative 1/3 to the x would be -0, -1. We're going to move it up 2, so that puts it back at 0, 1, but it's upside down now. So now it is going to look like this. And so where would our horizontal asymptote be? We can figure that out from the shifts as well, but we can also figure it out algebraically. So the original would be y equals 0. When you reflect it, it's still y equals 0. Now we're shifting it up. So we're going to shift the y equals 0 up. So now it's going to be at y equals 2. You can also, when x gets really large, that gets really large, 1/3 to that really large number is going to go to 0. And so that leaves us with 2 as well. So you can figure this out algebraically or using graph, either way. Domain, like I said, it's all real numbers. Range, now look at the graph. So that is at 2, that is at 1. That's not important for the range. Range would go from -infinity to 2. We don't include the 2, and then the asymptote would be y equals 2. Okay, so I think we'll stop there. We'll do compound interest on a separate video. But same shifting rules apply. In case you forgot, since we did those, we always do the vertical shift last. So you start with the horizontal shifts and the reflections and the stretches. Then you do the vertical last. So just keep that part in mind.